thank you as well. I'm Bill Fischofer. I'm with the Linaro Networking Group, and what we're going to do today is give an overview, an update on the ODP project. So a quick background of what ODP is. Open Data Plane is an open source, open contribution framework for portable high-performance data plane applications. Basically consisting of a common set of APIs which provide application portability and optimized implementations of those APIs to provide accelerated performance on each platform. We currently have a fairly wide architecture support, which includes both ARM, MIPS, PowerPC, and x86 so far. And what we're really focused on with ODP is providing portability without sacrificing performance, with the goal being to provide a wide choice in platform selection to match application price performance needs. LNG and its members are the ODP maintainers and its upstream. Okay, so if you look at the Linaro Networking Group, it was a series of companies that are come together to work on common problems, like all members within Linaro, common problems within a designated application area, in this case networking. So even though we're the sponsoring companies, the project itself is open source, open contribution, and is available under a BSD 3-clause license. If we look at the system architecture, it's a little washed out. The intent here is that we can support multiple apps, which can be on either shared or dedicated cores. And also, by providing a common framework, we can leverage existing SDKs running across either real or virtual hardware. That's sort of the vision for ODP. The design point is multi-core SoCs that can run Linux on at least one core. And what we're really providing with ODP is a framework rather than an environment, allowing existing apps to deploy ODP services incrementally. And this is illustrated here as to the structure of how ODP relates to applications. So existing apps can add ODP functionality on an incremental basis, because as we all know, very few programs are written from scratch. You have large existing bodies of code which have to migrate over time. So ODP implementations leverage existing SDKs, and however, we still allow applications to directly exploit either the SDK or the underlying hardware if they wish. So the idea is that to the extent that an application wants to be portable, it can start using ODP APIs. To the extent that it wants to get that last ounce of performance on a given platform, it can still interoperate with native facilities on that platform. So if we look at the in more detail here, the components, as I said, are the APIs, which are the common definitions, build tools, and validation tests. And these are open contribution with LNG serving as the maintainer and upstream for that. Whereas ODP implementations are developed and maintained by a sponsoring owner, which is typically an SoC vendor, and they are either integrated into the main ODP Git repository and maintained separately at the owner's option. So as I said, we don't dictate how you choose to distribute ODP implementations. We have a fair number of implementations that we're working on in the initial release. The main one, which we call Linux Generic, is open contribution maintained by LNG. This is a pure software implementation which runs on any Linux kernel. As a result, it's not a performance target. It's really there to provide an application proving ground, an API proving ground, and a easy method of bootstrapping ODP and its core applications onto any new platform, because all you need is a Linux kernel. Another one of interest is Linux DPDK, where again, it's open contribution. LNG has developed this initially. And the target platform here is Intel x86 platforms using DPDK as a software acceleration layer. So the idea being that you're still using ODP APIs, but underneath the covers, they're actually being translated into DPDK calls to accelerate on x86. We then have a number of member SoC implementations. There's one from Avago Technologies for their Axia family of SoCs, which is ARM Cortex-A15 based. Texas Instruments has an implementation for its Keystone 2 platform, which again is ARM Cortex-A15 based. Cavium has one for Octeon, which is MIPS64 based. Freescale has one for the QRIQ SoCs, and that's PowerPC based. And Applied Micro is working on one for their XGene process, which is ARMv8. And we're also aware that there are other implementations that are being developed by others outside of LNG that are looking to participate in the larger ODP ecosystem. So the design and development methodology we've been following is really iterative. So the idea here is that we're not smart enough to come up with a set of APIs that we know in advance are optimal. So what we do is we propose a set of APIs, we try them out on lots of different platforms, discover where the seams are, and then refine that based on the experience, with the idea being that a stable release 1 can be achieved when we have multiple efficient implementations validated for a variety of different network SoCs. And if you look at the project statistics, that sort of shows that iterative nature. Is that this is some data that I took as of last Friday from our Git repository, and so we have to date 216 files, about 55,000 lines of code, but that comprised 96,000 lines of code of adds and 41,000 lines removed. So we've been iterating on try this, no, we decided to refine it to do something else. 337 commits and a total of 26 authors to date. And I should point out that this does not include platform development work that's being done outside of the main ODP Git repository. So for example, a number of the implementations are not being integrated into the Git repository, so their work is not included in these totals. So a fair amount of activity over the past 11 months. Again, more statistics. These graphs, they show up better on the slides than on this projector because it's VGA. But we've had a total of 465 patches submitted and 178 upstreamed into ODP. A lot of the other patches are just basically iterations on version 1, 2, 3, etc. If we look at the project history, as I said, it's a fairly young project. We announced ODP last October at LCU14 here in Santa Clara. And as I said, at that time, we basically had a set of slides and some good intentions. We did deliver a preview release the following December last year. And that had basic functionality for threads and processes and queues. We also had an interim release that we demoed during LCA14 earlier this year in March. And at that point, we were able to show ping-type traffic running across a couple of different implementations. Over the spring and summer, we had quite a bit of intensive design and development activity, including 2 design sprints, one focused on crypto in April, and then a second one focused on classification, which was held in June. That brings us to today, where we're actually planning on having a number of demos, which we'll talk about later, that you'll be seeing on Thursday. And then we're planning on delivering our first actual full-fledged release by the end of this year. And we're looking to also, starting at this Connect, we're doing advanced planning for ODP 2.0, which we hope to deliver sometime next year. If we look at the where we are in terms of the various features that ODP 1.0 is offering in its APIs, buffers, classification, crypto, interprocess communication, and packet I/O. These are all different level areas of functional abstraction. So, for instance, a packet I/O object is an I/O channel, okay, logical or physical. Crypto is providing a set of APIs for doing algorithm offload for encryption, hashing, functions like that. Here's just some more list of things. So queues, scheduler, shared memory, and synchronizers. All of these we have various APIs that are defined that provide services in these areas. And threads and timers. Timers are just things that we've gone through really 2 complete iterations of the design. We had an initial design and then an improved design, which has just recently been integrated. So it's all part of the iteration that we're doing. For those who want to get involved in the ODP project, you can visit the website, opendataplane.org. We have a mailing list, which is open, and there's a lot of discussion activity on that. We also have a weekly call on Tuesdays at 1500 UTC, which on the West Coast would translate to 8 a.m. So given the span of time zones that people who are participating, it's either ranges from early morning to early evening. We try to pick a time that's mutually inconvenient for the extremes. And anyway, that is a open call, and anyone can participate in that just by going to uberconference.com/opendataplane. And then, of course, obviously, it's an open source project. We're always interested in people who want to contribute code, tests, documents, bug reports, etc. Any questions so far? Okay. There are a couple of other ODP sessions of interest which I wanted to point out that both people will want to check out. On Wednesday, Cisco will be doing a very interesting presentation on some of their experiences and work with working with ODP, since they're one of the LNG members and one of the key drivers behind ODP. And on Thursday, there's an interesting talk that Varesh will be giving on the isolation and no-hertz upstreaming progress. The intent behind this is to allow applications to take complete control of cores without interference from the Linux kernel. And in the data plane, just as in high-performance compute or other things, this is useful because it basically means that you can have complete access to that core without the overhead of the kernel constantly interrupting. And of course, on Thursday, we do have a number of demos planned, which will be held over in the, I think it's Suite E, okay, where they'll see the posters go up later this week. We have a number of demos basically showing ODP running and performing different applications across a wide variety of application platforms and SOCs, including IPsec routing, layer 2 forwarding, packet I/O across different architectures, as well as interacting with Open Daylight project and showing the Open Virtual Switch running on Open Data Plane as well. and a few others. And I understand that Cisco has a demo that they're also planning on doing, which we don't get on this chart, but we'll have that up as well. That's basically the update. We didn't have a lot of questions, but maybe we'll have some now. Yes, can we get that mic?
Hi, so Gilad Ben Yosef from EasyChip. Started being involved in ODP, as I guess some people know, and so the code is readily available. That's the cool part. But some of the design documents, some were very easy to find. Some up till this day, I'm not quite sure where to get the classifier and stuff. So I can understand if some of them, just doesn't exist, so nobody wrote a formal document. But I was just wondering if there's somewhere someone can go to see, okay, these are all the design documents that we have.
Yeah, that's all in the Open Data Plane website. The classification document was just, we had some problems with formatting on that, which were just resolved last week. So check there again, but that document is fully available now.
Okay.
On there.
Thank you.
And one of the major activities that's still needed is more documentation. My first manager had a sign in his office which said, "Everything comes to he who waits except documentation," and that's true for all projects, I think. So we're no exception on that.
Okay, thank you.
Anyone else?
So on these new APIs, the crypto API and the classification API, what is the planned level of support on Linux Generic and Linux DPDK?
So the crypto API is available on Linux Generic. It basically it uses OpenSSL to provide those APIs support, and that's where that's how it's saying. So again, it's not a performance implementation. For DPDK, we've done DPDK support as essentially a demonstration project, but the status of DPDK as an officially supported platform for ODP is still under discussion. Ideally, we'd like someone who is a main DPDK stakeholder to step up and say, hey, we want to provide this support on an ongoing basis.
So just a clarification, so is it expected that all of these APIs that are coming out, classification included, will always have a Linux Generic, at least?
Yes, the intent is that Linux Generic is essentially a proving ground for all of the APIs, so any API would be available there, although obviously not accelerated, suitable for development and test use, but not for production.
Bill, can I add a bit? Most of the platforms, apart from Linux Generic, ARM we would like to maintain, LNG would like to maintain. All other platforms, it is expected that the member companies or whoever is interested, they should maintain it in future. So, though the initial period is, we would help them, but later on it should be like a true open source project. So, respective user should maintain it.
So Barry Spinney from Tolera. What's the view of the, I noticed in the Git directory there's some ODP applications. Are they expected to be, real applications, production quality, or are they just expected to be test demos, or what's the goal there?
Well, right now we've focused on demos earlier, but I think there's people who are working on more serious stuff.
So what we're working on today is we have our data plane code, and actually I have a presentation that's this same time slot on Wednesday.
Yes.
Is that right? That we're talk about more details of that. But we have an existing code base that we have deployed on our multi-core, multi-threaded ASICs for several years now. And what I've been working on is actually porting that code to run on top of ODP as the basic infrastructure for receive, transmit, packet ordering, and buffer management. And so I think that might be probably one of the more advanced uses of it today. Although the IPsec example application does make use of like packet ordering queues to do sequence number assignment, that kind of thing. Our data plane code? No.
So, well, I mean, we are going to be showing Open vSwitch, okay, which is running on Open Data Planes. We have an adapter module for allowing it to run on that. There will be some. I think, you know, when you look at how the ecosystem in open source projects develops, it's really driven by end user interest and need, right? So if somebody says, hey, this is cool, I have a great app that I want to make run on this, go for it. I mean, that only helps everyone, both in terms of making your app more readily available across multiple platforms, as well as providing good feedback for, hey, we could further improve ODP by adding these features. What we see is the whole idea behind ODP is we started from scratch. So this past year we've been developing, you know, and aiming towards an ODP 1.0, and the idea behind ODP 1.0 means that this is now suitable for evaluation by the community at large. Okay, that it's mature enough that the APIs aren't going to change out from underneath you every week, so you can start playing around with it. There seems to be emerging consensus that the intent is that for ODP 2.0, we want to then have something which is suitable for production deployment, right? So that's just part of the natural maturation process of any project, that you have to have enough there so that people can, it has stable enough so that people can actually do serious evaluation and prototyping with it, and then based on that we can further tune and harden the interfaces so that it's ready for production use.
Bill, to his specific question, I mean the crypto demo app that was done, for example, was in no way meant for ultimately being a production piece of code. These are all really, so far, apps that are about demonstrating and exercising and validating APIs and infrastructure. And so, Bill, I don't know, I mean, do you folks have any plans of writing applications that would ultimately be upstream for production use?
Well, I mean, again, if people wanted to write applications and open source them, you know, they're welcome to do that. LNG itself doesn't have the mission to do that.
Exactly. Yeah. I think that's your question.
So, but what we are interested in is, you know, using some of these as perhaps part of a validation suite, okay, so that you can verify that when, you know, someone says, I have an ODP implementation, you know, then they had to get some sort of a certification process that basically says, yes, indeed, you know, if you run these tests and they pass, then indeed it conforms to the ODP1 spec.
Yeah, I think the validation suite is something that we see as being very important moving forward.
Exactly,
and,
yeah,
right.
for obvious reasons. There's no point of having multiple implementations if you can't reliably say that they're really implementing the same thing. Yes, Alex.
Thank you. So another question about, obviously because part of the target of doing this is to be able to supply the same interface across different implementation. But it's also obvious that you know, certain targets would be able to do stuff that other targets cannot or cannot do efficiently. Now, for some things, you could just say, okay, I have this feature is working very well because its hardware accelerated here, and here is working maybe slightly less well because it's not accelerated, it's done in software. But obviously, from time to time, there will be features that, you know, not everybody can do, so they would be marked, I guess, optional. The question is there like some sort of policy to say when are we putting stuff in, when are we putting it as optional, and when are we putting it mandatory? The tension for application writers, right? So they know what to expect.
Exactly. Well, that's part of the design process, which I know you've been involved with now. I think it's really a question of consensus. You're absolutely right that being portable doesn't mean that all platforms are identical, right? That's certainly not the intent, and nor could it be, because different platforms have different capabilities, price performance points. You know, I mean, you're not going to make a 1-core system look like a 64-core system, or a 128-core system, or a 1,000-core system. But on the other hand, not all applications are going to need, you know, 1,000 cores, you know, for a given deployment. So the intent is that we want to provide, through the application writers, a common set of APIs that they can easily achieve presence across a wide range of different SOCs, and that allows, in turn, the people who are looking to deploy those apps to select a platform that matches their price performance need for that particular deployment. Well,
some of the work, I mean, it's mentioned in the specification, but in the Linux generic implementation of the crypto API, it's not implemented yet. But the idea with the crypto was to be able to, for the application to query capabilities of the implementation. And so then the application could determine at runtime what the underlying system could do, and then adjust for that. And I think that concept will probably find its way to other aspects of ODP as well. And in addition, we've talked about, even with crypto, you know, there's the idea of discovering and handling at runtime, and there's the idea of doing it at compile time. And so we've discussed trying to, you know, the crypto has sort of been the litmus test, or the first try at how are we going to do a lot of these things. And so we're still been working through the kinks of how do you really efficiently, at build time, let a given implementation propagate some pound defines or whatever to efficiently let your application adjust accordingly. So that's still sort of a work in progress.
Okay.
You know, a la carte is a fundamental principle, I think, right? And that is to allow for varying implementations and varying underlying hardware, and to be able to pick and choose those and not have to accept, you know, the least common denominator for a given set of hardware.
Yeah, that was what I had in mind, right? So if you have all the optional features, the application writer, if it's targeting a certain platform, that's fine. But if it's targeting the most, then it will be forced to take the lowest common denominator. And so
yeah,
I think what you would do is you take hardware acceleration where hardware acceleration exists, and settle for a software implementation where the software exists, right? So to some degree, maybe the actual application doesn't know or care whether there's hardware or software under it. That's your business as a SOC vendor to decide whether you put a driver in to leverage your hardware, or whether you put in a software implementation, right? If I want my application to do something, whether you do it in hardware or software is your business, but that's what you're going to provide to me.
So if I get you right, so the expectation is that over time, the ODP API will include more and more abstractions for stuff like, I don't know, lookups, counters, and so on, which will either be soft or whatever.
Yeah, and Blake is absolutely right. So the idea is just to provide ranges of options and choice. So each SOC vendor says, okay, these are the set of mandatory APIs. We will accelerate what makes sense in hardware. We'll provide software implementations, you know, for the balance, and then for an application deployer, okay, which says, hey, I want to deploy application X for this type of use. Well, what do I need? I know that I want real, you know, hardware acceleration for these features. You know, what's the list of SOCs that provide that? You know, then they, you know, that sort of narrows your choice for which ones to consider for deployment.
Okay, thank you.
You can even show the slide that is
Which
block diagram, the third or fourth.
Oh, yeah. This one?
Prior to that. Yep.
Yeah. So again, if we look at here, the ideas behind the ODP implementation. So again, these can operate either in hardware or software. They can call directly into hardware, or they can go through an existing platform SDK. We don't specify how you implement a particular API. That's you know, within the domain of expertise of the SOC vendor.
I guess. Well, the expectation is to provide as much API as possible so that each one can choose whether or not to
We
accelerate.
definitely do not want a least common denominator where you have, such weak APIs that nobody is really interested in using any of them.
Okay, thank
You
you.
really want a rich level of functionality, but not an impossibly high bar where everyone has to do everything in software because only one platform ever has, that. But over time, you would expect that, the level of abstraction and level of capability would increase, because, hardware designers are constantly cleverly coming up with new things, and one of the real purposes of coming up with really good APIs that a large number of applications are going to be interested in using is that gives the hardware designers free rein to say, hey, we can do this API in hardware very cleverly. So.
Okay, thank you.
So I have a specific one. You're talking about the crypto stuff, and I have a very specific case that came up recently, and I actually bumped into this with an IPsec implementation, and it has to do with that we had an implementation for all the IPsec crypto protocols, but only up to 4,000 bits. Well, IPsec has some Diffie-Hellman things going up to 6,000 bits. So there are a couple ways one can look at that from ODP's point of view. One way is that ODP app says what's your biggest key size, and they would come back and say 4,000, in which case then it'd say, okay, if I want to do 6,000, I'll call my software implementation. Or alternatively, the ODP could say, no, if you're going to supply this crypto capability, you have to do it for everything up to the max, and therefore it's ODP's implementation that has to say, oh, I can't do anything more than 4,000 in hardware, I'll ship it off to my software library. Two very different approaches, and I think you guys got to decide the philosophy.
Yeah, I think that's exactly what the community design process is all about, because we're the ones that decide, does it make sense, from a ecosystem standpoint to say, this is where the line should be drawn. Okay, and one would assume that those lines would change over time because technology matures. So. Okay. Anything else? All right, well, thank you all very much. This has been a very good exchange, and we hope to see you on the mailing list and participating in our weekly design calls as we move forward. Thank you.